Hello everyone, I'm Shuchita, PhD student from Biophysics Lab at ISER Mohali, and today I will be talking about my work where I understand biophysics of lipid hydrolysis. So first of all, let us understand about biophysics. What is biophysics? Biophysics happens when physics refuses to stay in its lane and biology has to say, okay, fine, let us make it useful. So yes, we ask inconvenient physics about biology. And what would be the best way to begin with if not the cell? And here are the different examples where you could be doing and learning about biophysics. So what do we do is we zoom here at the membranes where things get more interesting. Like this. So cell membrane is highly dynamic and it is like a door to the cell where not everything can enter. Like when you go to a club, you meet a bouncer, and not everyone can go through. So, cell membrane can be way more selective than any club will ever be. So, that time also, if you cannot get across, you sometimes ponder. So, here also, like you ponder why these membranes are more like moody liquids than a solid barrier, and how these tiny molecules can make big changes in the cell, and how if the things are continuously getting in and out of the door and is continuously changing and is stable at the same time. So before we understand and we answer these questions, so we should know about our membranes. So let us know more about our membranes. So our membranes are highly dynamic structure and are like a door to the cell, where they are made up of phospholipid bilayer, proteins and sugars. So phospholipid bilayer has two faces, well better than most of the people, where they have many faces and are impossible to read. So what I was saying is this phospholipid bilayer has two faces with extracellular and intracellular side, which is towards, that's how they are named, intracellular side towards the cytoplasm and extracellular cell towards the other cell or outside the cell. This is the hydrophilic part of the phospholipid bilayer. That's why it interacts with water and is facing towards the water. And these are the hydrophobic tails, which are sandwiched in between and are away from the water. So this is how a general phospholipid structure looks like. Here you can, at this highlighted points, you can change different structures, and with different permutation and combination you can get diverse variety of phospholipid molecules. And yes, these molecules are the most abundant lipid at the cell membrane. But this membrane is very complex. It has phospholipid bilayers, proteins, and sugars, as I have mentioned, which makes it very complicated. And for us, it is very difficult to understand our problems. So, what do is we simplify this system by making a model membrane system, which looks like this. This is an example of vesicular model membrane system. Similar arrangement as that of cell, lipid phospholipid bilayer, where hydrophilic head is towards the water and hydrophobic tail is sandwiched in between. So this system can be further subdivided into different types based on lamellarity, unilamellar system, multilamellar system, and multivesicular system. Unilamellar system can be further into divided into different types such as small unilamellar vesicle system, as the name suggests, are the smallest, then large, and the largest are the giant unilamellar vesicles. So we use giant unilamellar vesicles for our study. Well, obviously, first of all, they are big, they're easy to manipulate, they give us the liberty to tweak and do the manipulation, and yes, they are also similar to some of the cell size. That's why they are commonly used in membrane biophysics studies and synthetic biology studies. So this is how a UV look under a phase contrast microscope. So this black boundary is a lipid bilayer, and inside out is same, in this case buffer. Here it is sucrose. So if you zoom at this membrane, at this lipid bilayer, it looks like this. The phospholipid bilayer arrangement is similar. So as I was saying, the phospholipid are the most abundant molecules in the lipid. So what if we modify these phospholipids? Do we get a chance in regulating the mood of the cell? So this is a structure of common phospholipid, hydrophilic head, and these are the hydrophobic tails. So the structure of tail can vary depending on the saturation and unsaturation. So if we modify these molecule, can we modify our membranes? Well, yes, there are molecules which can do this, and phospholipases are the enzymes that hydrolyze these phospholipids. So they come in different packs depending on where they cleave. So I'm interested in phospholipase A2. I work with phospholipase A2. It cleaves at the SN2 position of a phospholipid, generating a lysophospholipid and releasing a free fatty acid. So here you can see this is a phospholipid with one head and two tails, and after the activity of enzyme it has now one head and one tail, which is a lysophospholipid, and a free fatty acid is released. So preferential substrate of phospholipase A2 is phosphatidylcholine, and this biochemical reaction is very important and crucial in membrane remodeling. Since phospholipids are most abundant, so this activity is one of the most important reaction happening in the cell. So that's why they can be found almost everywhere, such as in neurological disorders, metabolic disorders, inflammatory and development pathways. And what makes them special is they are commonly found in venom of different animals, such as scorpions, snakes, and bees. So, yes, probably if you are bitten by a snake, and there is a teeny tiny chance where you can unalive yourself, well, not teeny tiny, big chance, maybe, where you can unalive yourself. So this phospholipase A2 molecule probably has something to do with it. And also when this happens, well, this happens to I think many of us. When this happens, here also again phospholipase A2 has something to do with it. So what do I do is I ask physics behind all this biology. So what do I do is I take a GUV. I take my model membrane system GUV, make them interact with my enzyme phospholipase A2, and I observe and ask and notice what are the changes, how it is affecting lipid packing, membrane curvature, membrane charge, change in shape and size, and the membrane fluctuation and forces. So why am I doing this? Why should I study and knowing all about these parameters? Well, first thing is key. Well, one thing is I have changed my lipid. Basically, I have changed the mood of the cell. Mood of the cell by changing these lipids, which regulates the mood of the cell. So by changing it, I am modifying the mood of the cell. So how if this changes, it interacts with other molecules. So will it become more generous and more welcoming with open hands, welcoming all sorts of molecules, or will it become more sassy by charging a lot and yes, not so welcoming at all? So this is what I'm trying to understand and trying to learn through my work. So that's all. And if I have to conclude and summarize, so yeah, by doing biophysics, we don't ask how life works. We ask why does it work despite all the chaos and disturbances. But like these, so this is my lab. And if you have any query, you can write me here. And if you would like to meet us, you can find us here at ISA Mohali. Also, just a tip, upping would be always better because we like working with these multilipids. We are also now like them. We can be sometimes more generous and we can be very sassy sometimes. So yes, a ping, a prior information will always works like a charm. And if you would like to know more about us, you can check our lab website. So that's all. Thank you and bye.